Our star, the Sun, a journey through time. Our Sun, a brilliant star in the Milky Way galaxy, has been captivating humanity for millennia. It provides the light and warmth that sustain life on Earth. But like all stars, the Sun has a life cycle. It was born, it will evolve, and it will eventually die. The Sun formed about 4.6 billion years ago from a massive cloud of gas and dust. This cloud collapsed under its own gravity, pulling material inward and spinning faster and faster. The center of this swirling cloud grew hotter and denser, eventually reaching temperatures and pressures high enough to ignite nuclear fusion. Hydrogen atoms fused together, creating helium and releasing an enormous amount of energy. This marked the birth of our Sun. The Sun is currently in its main sequence stage, where it will spend the majority of its life, about 10 billion years. During this stage, the Sun fuses hydrogen into helium in its core, generating the energy that powers our solar system. This process creates outward pressure that balances the inward pull of gravity, keeping the Sun in a state of equilibrium. However, this equilibrium won't last forever. As the Sun ages, it will gradually exhaust the hydrogen fuel in its core. This will cause the core to contract and heat up, while the outer layers of the Sun will expand and cool, transforming it into a red giant. When massive stars, much larger than our Sun, reach the end of their lives, they die in spectacular events called supernovae. These explosions are so powerful that they can outshine entire galaxies for a brief period. The remnants of these stellar explosions can take many forms, one of which is a black hole. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape. They are formed when the core of a massive star collapses in on itself under its own gravity. This collapse compresses the core to an infinitely small point called a singularity, which is thought to be at the center of a black hole. The singularity is surrounded by an event horizon, a boundary beyond which nothing can return. Once something crosses the event horizon, it is trapped inside the black hole's gravitational grip forever. Black holes are incredibly fascinating objects that challenge our understanding of physics and the nature of reality itself. Given their immense power, it's natural to wonder if our Sun could one day transform into a black hole. Thankfully, the answer is a resounding no. The Sun simply lacks the mass to become a black hole. Black holes form from the remnants of stars that are at least 20 times more massive than our Sun. These stellar giants have enough mass to overcome the outward pressure generated by nuclear fusion and collapse into black holes at the end of their lives. Our Sun, however, is classified as a yellow dwarf star, a relatively small and common type of star. When it eventually exhausts its hydrogen fuel, it will expand into a red giant, engulfing the inner planets, including Earth. Afterward, it will shed its outer layers, leaving behind a dense, hot core known as a white dwarf. While the Sun won't become a black hole, its eventual death will have profound consequences for Earth and the solar system. As the Sun expands into a red giant, its increasing luminosity will boil away Earth's oceans, rendering the planet uninhabitable. The outer planets, once frigid ice giants, may experience a temporary period of warmth as the Sun's habitable zone shifts outward. However, this reprieve will be short-lived. When the Sun sheds its outer layers, it will become a white dwarf, a faint ember that will slowly cool and fade over billions of years. Without the Sun's energy, the solar system will plunge into darkness and extreme cold. The planets will continue to orbit the Sun's remnant, but the once vibrant solar system will be a stark and desolate place. Section 5. A universe of unfathomable size and age. Our solar system, while vast and awe-inspiring, is but a tiny speck within the grand tapestry of the universe. The universe is so vast that its size is difficult to comprehend. The observable universe, the portion we can currently observe from Earth, is estimated to be about 93 billion light-years in diameter. To put that into perspective, 1 light-year is the distance light travels in 1 year, which is about 5.88 trillion miles. This means that the observable universe is billions of trillions of miles across. The actual size of the universe, including the parts we cannot currently observe, is likely much larger, perhaps even infinite. The age of the universe is another mind-boggling concept. Scientists estimate that the universe began with the Big Bang, a colossal explosion of energy and matter, about 13.8 billion years ago. Section 6. The ever-expanding cosmos, a journey into the unknown. One of the most remarkable discoveries in cosmology is that the universe is not static, but is constantly expanding. This expansion was first observed in the 1920s by astronomer Edwin Hubble, who noticed that distant galaxies are moving away from us. Furthermore, Hubble's observations showed that the farther away a galaxy is, the faster it is receding from us. This relationship between distance and velocity is known as Hubble's law and provides strong evidence for an expanding universe. The expansion of the universe is often compared to the inflating of a balloon. As the balloon inflates, the dots on its surface move away from each other, just like galaxies are moving apart in the expanding universe. It's important to note that this expansion does not mean that the universe is expanding into something else. Rather, it's the fabric of space-time itself that is stretching, carrying galaxies along with it. Section 7. Dark Matter and Dark Energy. Unraveling the universe's biggest mysteries. While we have made significant strides in understanding the universe, there are still many mysteries that continue to baffle scientists. Two of the most perplexing enigmas are dark matter and dark energy, invisible forces that appear to make up the vast majority of the universe's mass and energy. Dark matter is a hypothetical form of matter that does not interact with light or other electromagnetic radiation, making it invisible to telescopes. Its existence is inferred from its gravitational effects on visible matter, such as stars and galaxies. Scientists estimate that dark matter makes up about 85% of the total mass of the universe. Dark energy, on the other hand, is a mysterious force that is thought to be responsible for the accelerating expansion of the universe. Observations of distant supernovae have shown that the expansion of the universe is not slowing down as expected due to gravity, but is instead speeding up. This unexpected acceleration is attributed to dark energy, which is thought to make up about 70% of the total energy density of the universe. Section 8. Exoplanets. A universe of possibilities. For centuries, humanity has gazed up at the stars and wondered if we are alone in the universe. While we have yet to find definitive evidence of extraterrestrial life, the discovery of exoplanets, planets orbiting stars outside our solar system, has revolutionized our understanding of the cosmos and fueled our search for life beyond Earth. Exoplanets come in a wide variety of sizes, compositions, and orbital configurations. Some are gas giants larger than Jupiter, while others are rocky planets similar in size to Earth. Some orbit their stars closely, completing an orbit in just a few days, while others orbit at vast distances, taking hundreds or even thousands of years to complete one revolution. The discovery of exoplanets has opened up a universe of possibilities, suggesting that planetary systems are common in the Milky Way galaxy and beyond. It is estimated that there are billions of exoplanets in our galaxy alone, many of which could be potentially habitable. Section 9. The search for life beyond Earth. Are we alone? The search for life beyond Earth is one of the most profound scientific endeavors of our time. Scientists are particularly interested in finding exoplanets located within the habitable zone, the region around a star where conditions are just right for liquid water to exist on the surface of a planet. Liquid water is considered essential for life as we know it, so planets within the habitable zone are considered prime candidates for hosting extraterrestrial life. While the presence of liquid water is not a guarantee of life, it is a promising sign that we should investigate further. Scientists are using a variety of techniques to search for signs of life on exoplanets, including looking for biosignatures in their atmospheres. Biosignatures are chemical compounds or patterns that could indicate the presence of life. For example, the presence of oxygen, methane, or other gases in an exoplanet's atmosphere could be a sign of biological activity. Section 10. Pulsars, neutron stars, and black holes, extreme objects in the universe. The universe is home to extreme objects that push the boundaries of physics. Pulsars, neutron stars, and black holes are remnants of massive stars. Pulsars are rotating neutron stars emitting beams of radiation. These beams sweep across space like lighthouse beacons. Neutron stars are the collapsed cores of supernovae. They are incredibly dense, with a mass greater than the sun. Black holes are regions where gravity is so strong that nothing can escape. They are among the most mysterious objects in the universe. Section 11. The Wonders of the Cosmos, a never-ending journey of discovery. The universe is a vast and awe-inspiring place, filled with wonders that continue to amaze and inspire us. From the birth and death of stars to the expansion of the universe, from the search for exoplanets to the study of black holes, there is no shortage of mysteries to unravel and discoveries to be made. As we continue to explore the cosmos, we are constantly reminded of the vastness and complexity of the universe and our place within it. Each new discovery raises more questions than it answers, pushing the boundaries of human knowledge and challenging us to expand our understanding of the cosmos. The journey of cosmic discovery is a never-ending one, and it is a journey that we are privileged to be a part of.